In this video, we learn Fourier series of the function f of x is equals to e power x from the interval 0 to 2 pi. Let us see the solution. Given that f of x is equals to e power x and that x lies between 0 and 2 pi, 0 less than or equals to x less than or equals to 2 pi. The Fourier series for the function f of x, the Fourier series expansion is given by f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx plus summation n is equals to 1 to infinity bn sin nx. Here a naught is equals to, the term a naught is equals to 1 by pi integral 0 to 2 pi f of x dx. Here our function is e power x, integral 0 to 2 pi e power x dx. Everybody knows integral e power x is equals to e power x. So this is simply 1 by pi e power x limits 0 to 2 pi. So 1 by pi e power 2 pi minus e power 0. E power 2 pi minus e power 0. E power 0 is 1. So e power 2 pi minus 1 by pi. Therefore, a naught is equals to e power 2 pi minus 1 by pi. We find the value of a naught. Now we go for an. An is equals to 1 by pi integral 0 to 2 pi f of x cos nx dx. So what is f of x? E power x. So 1 by pi integral 0 to 2 pi e power x cos nx dx. This integral is in the form 1 by pi integral 0 to 2 pi e power ax cos bx dx. But where a is equals to 1, b is equals to n. So we know that the integral of this form can be equivalent to 1 by pi 1 by a square plus b square into e power ax, or e power ax by a square plus b square into a cos bx plus b sin bx. Remember this formula and practice it more and more number of times. I repeat the formula. Observe that integral e power ax cos bx dx is equals to e power ax by a square plus b square into a cos bx plus b sin bx Practice this formula. Practice more and more times. If you remember this formula, then this integration becomes very simple and easy. So in our problem, we have a is equals to 1, b is equals to n. 1 by pi, a value 1. So e power x by 1 plus n square into 1 plus n square into cos bx, I mean cos nx, not b. B instead of b we have n. Cos nx plus sin nx. Cos nx plus sin nx. But instead of b you have to write n sin nx. And the limits are x equal to 0 to x equal to 2 pi. Now substitute the limits. 1 by pi into 1 plus n square. Limits, upper limit, e power 2 pi cos n 2 pi plus n sin n 2 pi minus lower limit e power 0 cos 0 plus n into sin 0. upper limit minus lower limit, which is equals to 1 by pi into 1 plus n square e power 2 pi cos 2n pi 1 sin 2n pi 0. I repeat the formulas. Cos 2n pi is equals to 1 for all n belongs to z, and sin 2n pi is equals to 0 for all n belongs to z. These two formulas holds. And also cos 0 degrees is equals to 1, sin 0 degrees is equals to 0. Using these terms you get e power 2 pi, e power 2 pi. In the first term we get, here it is 1, here it is 0, here it is 1, here it is 0. So simply you get e power 2 pi minus 1, e power 2 pi minus 1. So you can write like this, e power 2 pi minus 1 by pi into 1 plus n square. This is nothing but an. So we find an also. Now we go for bn. Bn is equals to 1 by pi integral 0 to 2 pi f of x sin nx dx, which is equals to 1 by pi integral 0 to 2 pi f of x e power x sin nx dx. Again this is in the form of, this formula is in the form of 1 by pi integral 0 to 2 pi e power ax sin bx dx, where a is equals to 1, b is equals to n. By applying this formula you get 1 by pi e power ax by a square plus b square into a sin bx minus b cos bx, a sin bx minus b cos bx, limits 0 to 2 pi, remember that. So this is again a formula. I repeat the formula here, learn carefully. Integral e power ax sin bx dx is equals to e power ax by a square plus b square into a sin bx minus b cos bx. Remember that. Already we learned a similar formula here. There we have cos bx. Now here we have sin bx. Remember the difference and learn the formula. Now substitute the limits. Simply we get 1 by pi into a means 1, b square means n square, a means 1. So you get e power 2 pi. I write just e power ax. Okay. In the first I write substitution and then I simplify. Okay, I'm going to directly. So 1 by pi e power x, a value 1, e power x by 1 plus n square, b value 1 into sin nx minus b value again n cos nx. So already I give the values for these sin and cos. Here it is. See, cos 2n pi 1, sin 2n pi 0, cos 0 1, sin 0 0. These are very important to learn the Fourier series. So now we substitute our values 1 by pi into 1 plus n square. I am substituting the upper limit e power 2 pi sin 2n pi minus n into cos 2n pi. This is upper limit minus lower limit e power 0 sin 0 minus cos 0, n into cos 0, upper limit minus lower limit. So simply we get minus n into e power 2 pi minus 1 divided by pi into 1 plus n square. So this is nothing but bn. Therefore bn is equals to minus n into e power 2 pi minus 1 divided by pi into 1 plus n square. Now substituting all the values of a naught, an and bn, using a naught an bn in Fourier series expansion. In Fourier series expansion, we get f of x is equal, what is the Fourier series? F of x is equals to a naught by 2 plus summation n is equals to 1 to infinity an cos nx plus summation n is equals to 1 to infinity bn sin nx. So what is f of x? E power x. We find a naught. A naught is equals to, here it is, an a naught is equals to e power 2 pi minus 1 by pi. So you can simply write like this: a naught by 2, a naught by 2, e power 2 pi minus 1 by 2 pi plus summation n is equals to 1 to infinity. What is an? We find an is e power 2 pi minus 1 by pi into 1 plus n square into cos nx plus summation n is equals to 1 to infinity. What is bn? We find the same values with a slight difference: minus n e power 2 pi minus 1 divided by pi into 1 plus n square into sin nx, which is required Fourier series for the function f of x is equals to e power x in the interval 0 to 2 pi. That's it. I give a problem for practice. Find Fourier series. Do homework. Find Fourier series of the function f of x is equals to e power ax in the same interval 0 to 2 pi. In our problem here, instead of e power x, use e power ax. So try to solve this problem to understand Fourier series, right? At the same time, remember these formulas. These are very, very important. Integral e power ax sin bx dx is equals to e power ax by 1 plus e power ax by a square plus b square into a sin bx minus b cos bx. There is a similar formula we have. Integral e power ax cos bx dx is equals to e power ax by a square plus b square a cos bx plus b sin bx. And to learn these also, cos 2n pi is equals to 1, sin 2n pi is equals to 0, cos 0 is equals to 0, sin 0 is equals to 0. That's it. In the next video, we learn one very, very, very important problem in the Fourier series expansion. Keep learning. Wish you all the best.